Algebra tiles are mathematical manipulatives that can model and represent numbers, equations, and expressions. We have 6 different algebra tiles that we use. For example, to model 5, you would use 5 of the positive 1 tiles. To model 5x, you would use 5 of the x tiles. We will use these throughout mathematics to model and think about how to make our mathematics visual. How do we find the sum 3 plus 2? In addition, in elementary school, your teacher would ask you to find a sum like this. You would go and you would find different counters or different manipulatives, and you would physically join the sets together to find their sum. We will do the same thing with algebra tiles. We will take 3 positive 1s and 2 positive 1s and join that set together and create 5 positive 1s. So therefore, the sum of 3 and 2 is positive 5. Now we're going to model addition with integers. We have 4 plus negative 2. So we're going to take 4 plus 1s, 2 negative 2s, and we're going to join these sets together. And what we notice happens is when we bring a negative 1 and a 1 together, we make a 0 pair. So that 0 pair is eliminated from our sum. We have another 0 pair that's made, and what is left over at the end of the modeling is 2 positive 1s. So therefore, the solution, or the sum, is 2. Now we're going to model negative 3 plus positive 1. We have 3 negative 1s and 1 positive 1. We can create 1 0 pair and eliminate 1 0 pair. We're left with 2 negative 1s. Our sum is negative 2. Now, to find the sum of negative 3 and negative 2, it's very similar to when we had positive 3 and positive 2. We model this with 3 negative 1s and 2 negative 1s. We join our sets together. We have 5 negative 1s. The sum of negative 3 and negative 2 is negative 5. Subtracting integers. In the elementary school, 5 minus 2, the difference of 5 and 2, you would have found 5 physical counters. Could have been a bear, a block, whatever was at your hands. Today, we're going to use our algebra tiles. I have 5 1s. That models my 5. Now, to show the difference between 5 and 2, I remove 2 tiles. Left with 3 tiles. The difference of 5 and 2 is 3. Now let's think about this with integers. 4 minus negative 2. We need to remove negative 2 from our 4. We don't have any negative 2's currently. So what we need to do is we need to change our tiles so that we can remove negative 2 without changing the value of 4. We can do this by adding 0 pairs. If I add 1 0 pair, the value of the tiles on my board is still 4. I have 5 positive 1s and 1 negative 1. I'm going to add a second 0 pair. Again, the value of all of the tiles in front of you, the 8 tiles in front of you, is 4. Now, I can take 4 and I can remove negative 2. The value here is 4. I remove negative 2. I am left with 6 positive 1s. 4 minus negative 2 is 6. Now the subtraction we're being asked to model is negative 2 minus 3. I modeled my negative 2 with 2 negative 1s, and now I need to take away 3 positives. Again, I don't have any positive values here to remove. So I must add 0 pairs. And in fact, I must add 3 0 pairs. The value of my board here is still negative 2. But now I have positive 1s to remove. So I can remove my 3 positive 1s. And what we're left with is 2 negative 1s, 3 negative 1s. So we have 5 negative 1s. I often find when we're subtracting negatives, it's easiest to say it out loud to help us visualize it. We have negative 5 and we're going to remove negative 2. Negative 5 is modeled there in front of you. To remove negative 2, we're going to take away 2 of the algebra tiles. We're left with 3 negative 1s. Negative 5 minus negative 2, negative 3.